Yes, yes, yes.
All right. Just one sec. Okay, so I'm super excited to be here this evening because I see it as a privilege to give back to the community that that molded and shaped me. So everything I know about data and in the field of NLP were all made possible by with this platform or on this platform, Data Science Nigeria, now known as Data Science Network. So this evening, I'm not taking this section alone. I'm running this section with one of a senior colleague also in NLP by name Dorcas Ibewu, and she'll be coming in to take us on another aspect of this within the time frame of this section. So what to expect, right? So this section, it's going to be a build up on the first section of NLP, introduction, application of industry application of NLP that one of our mentors, so I think that was sometime in May this year, if I'm not mistaken, by name Jyotika Singh. And I will encourage everyone, advise everyone on this call to listen to that section. But if you have already listened to it, then yeah, you're welcome to follow on this. But I'll try and do a recap of that particular section. Then we'll look down to what NLP is and look at the application of NLP. Taking it a step further, we look at language in reality. You see, in the world today, we have over 7,000, about more than 7,000 languages in the world. To be precise, 7,151 languages in the world. And it's kind of amazing because the majority of the data format we have is in text language, and the text language comprises of language that we humans speak. So you see that it becomes interesting for us to see the language in reality, look at some of the ambiguities that we've spotted out in language, and try to see and appreciate the state of art that has been reached in the field of NLP, making computers to understand this language. Then we'll look at basic definition in NLP, which will set the tone of this section and subsequent ones in subsequent sections as regards to NLP. We look at types of NLP, components of NLP, then basic background theories in NLP, and conclude it with the benefits of NLP for businesses. If we have time, we entertain questions and close at that point. So just a recap, if you see my screen, I believe, please, if you can see my screen, just say yes. Let me be sure that before I kickstart, before I move on to the fast lane now, please just drop on the charts. Yeah, if you can see my screen. Okay, that's fine. Great. Thank you so much. And thank you so much, everyone that tuned in. It's really amazing. Thank you so much for joining in this section and for us to learn together. Okay, so I copied this from one of my first line connection on LinkedIn, where she said that if you haven't already guessed that we are moving towards text to everything in artificial intelligence development. So that's the truth about it: text to image, text to Excel, text to video, text to movie. But the one thing that is more attractive to me on this is, for the last 24 years, we've been honing our Google search skill set with short bursts of text and for the next 24 years, we'll be honing our skill set and test to everything. Just think about it. Pause for a minute and think about this. So that will give you the basic background of why NLP is a very good career path one can chant, or it's a very good field that every industry actually needs this. Okay, so part of the first section on application of NLP, we looked at exactly what NLP means. And if you look at the state of art, or if you look at computer itself, you see that computer devices or computer systems itself, they are genius in trying to learn from language, creating it in tabular form. Sorry, trying to learn from spreadsheet, creating it in tabular form, trying to learn from facts and figures or information systematically when displayed in numerals. I mean, they've actually achieved that state of art. However, we human actually communicates with words and not with this numeral. So the point comes that there was a point where if majority of the test data, or like the previous slide that I showed, when everything will be turned to test. So if we want computer to harness the information and intelligence embedded in that text, then there is need for computers to learn how to understand language, how to understand this text in order to make the serious or inferential meaning to the real world scenarios. So that's the problem statement that gave birth to NLP. And NLP in its state is just the notion of empowering computers to communicate in human language. So it's an interdisciplinary, because you can't just say language itself. You can't just talk about language in isolation. So it's an interdisciplinary field that combines computer science, it combines artificial intelligence and linguistic itself, which is the language. And the skillful use of languages is what makes part of human. So we could say that the desire for computer to speak our language has been a desire, and that is exactly what led to NLP. As a result, we've seen different AI systems that have been designed around NLP. So the first is the speech recognition. We all use smartphones. We've heard about Cortana, Siri, Alexa, and the likes of them. So these are typical examples of NLP platforms that are on our smartphones. And it will keep increasing as time goes on. So I'll still repeat it, to watch the first learning section where these things were talked about in detail. Then the next one is the name entity recognition. This is a powerful system, AI system. And what this does, what this entails is it's trying to locate the key informations embedded in a text or most important details and classify them into a number of predetermined categories. That's where recommended system comes into view. That's where topic modeling and the likes of them. And this is done in two steps. One, it tries to dictate the entities from the text. And the second one is trying to classify them. When we look at machine learning translation, I mean, this is the biggest, because I personally have not seen someone who can speak 7,105 languages. I mean, I think I've seen someone who can speak 20 languages fluently, but just drop in a chat in case you've seen someone who can speak over 100 languages. And when you look at the way things are going, we have machine learning translation. I'm not sure if it was CAF end of year award that they were speaking French all through. So I'm like, is it that the thousands of people in this room actually understands French? But when I looked closely, I'll see that they were putting in there is a piece of earpiece that they put in their ears, and I'm like, okay, are they listening to music or something? And when I looked across, it seems everybody there are wearing it. And in the last Balloon d'Or, you could see Messi also putting that piece of ear. So that's a piece of device that tries to translate the word or the language to that person wearing it, or based on the language the person understands. And that is what machine translation is all about. So it's the process by which computer tries to translate a text from one natural language, be it English or be it Chinese or anything, to another form, depending on what that person understands. So there are a lot of apps like that. And I remember there's this app that helps me so much, because I have some colleagues who speaks English but hardly understands. So I use Google Translate, and it makes more sense to me. So when I speak in English, it translates it to their language, and it creates that communication, builds that communication. These are wonderful AI systems that have been built in NLP. But before it got to that point, there are some things you need to know. There are some things, challenges, ambiguities in language that were overcome to create that state of art. And this is the basics of you trying to, or if you are in the process of transitioning into NLP. So more systems of AI created. We have documents, summarization, we have spam dictation, question and answer, chatbots, predictive typing, and the lists can continue. When you look at the slide there, you will see part of the things I've talked about, what you can do with these AI systems, how these AI systems can be applied. I mean, the list, this is not just what you can do with Siri, with Alexa, with Cortana, and it's so much. And what it tries to do, what all of these things try to do is to make life very easy, to make things simplified. So the aim of NLP is to process or comprehend natural languages in itself in order to carry out useful tasks. Through the tasks will be making appointments, purchasing items, responding to inquiries or queries, using spell checkers, like Grammarly, keyword search engines, machine translations, spoken dialogue systems, or we have trying to fully understand and represent the meaning of languages. And it's not a standalone system. So languages are there, then we now have the AI aspect of it that backs it up. All right, so let's look at language in reality. Let's look at language in reality. You see, I believe you would have seen some people who can speak different languages. And I believe to some extent, it may be difficult learning. Let's say if you want to learn a language, it may be difficult learning. But some people also, they find it difficult speaking, but they can understand it properly. And if these are the challenges human beings are facing, how do we now make systems also to understand that? So basically, when we want to learn language, you start with the simplest forms of a particular language. For example, the basic greetings, the good morning, some people will tell you if you want to learn a language, learn the bad side of it. I mean, how when you want to call someone or something, that creates a faster way of learning and the likes of them. So you see something like you learn how are you and the likes of them. You see that it's not that difficult to perform an NLP, but the challenging part here is a word may mean something else in another language. That's the truth. That's one of the reality in language. Because now the question is, how do we make computers to understand that? Because I've seen two people fighting. I've seen two people in a serious combat. And what was the contest or what was the problem? Oh, this person used a word that means a praise word, but to the other person, Mr. B, that word is a derogatory word in his own language. I'm not like, so you mean you called me this? No, but yes, I called you this, not knowing that in this language, this means a different thing altogether. So it becomes a problem. Now, it's not just the meaning of the word, but how do you interpret it? How do you interpret it? For example, let's look at this example on the board, example on the screen. I saw Haaland in the pitch. I mean, I believe most of us are football lovers and we know who Haaland is. Haaland is a footballer, just to digress a bit and to give a context to this, in one of the Premier Leagues. And I think a few weeks back, a petition was signed. A petition was raised against him for him to be banned in Premier League. And within 24 hours, 2 million people signed that petition. And what was the petition talking about? The petition is all about, no, this guy is not a footballer. This guy is a robot. I mean, it's kind of strange, right? Because the kind of amazing goals, how he does it and all that. Well, that's just a bit of digression, but let's look at the context here. You said, I saw Haaland in the pitch with a ball. Now, you could call different people to give interpretation to what their understanding of this, and you can get an interpretation or someone saying that I was at the pitch and I saw Haaland with a ball. That is also a good one, because one, for the person to see Haaland in the pitch, two things is either the person is close to the pitch or is in the pitch to see that Haaland is with the ball. But you can see that there's a different interpretations to it. Now, another interpretation could be Haaland is on the pitch and wants to play football. Yes, Haaland is a footballer. So if he's on the pitch and with a ball, it means he wants to play football. So another interpretation could be, I saw a ball on the pitch and Haaland was there. So these are interesting things about language and the realities about language in itself. Now let's look at the second example. You see something like, I'm from the bank and I saw a bank. I mean, computer will be like, hold on. What are you trying to, if you are trying to process this in the system to tell you that these challenges have been overcome. So when you put these things in the system, even at now, there are some informations or commands or instructions or sentences you make to Siri or Cortana, they'll be like, I'm not sure I understand this. Please do you mean this or something? If you're used to some of these tech devices, you see that some of these things, I mean, these are practical things that you see with all this, with all of this. So I am from the bank and I saw a bank. So now you just be like, okay, we have a word there, bank, meaning two different things. And the word bank could mean a financial institution. The word bank could mean the land alongside or is sloping down. And it could also mean a heap of mess or dirt in a mode. So these are the language in reality that creates a lot of ambiguity. And before I talk about all of this ambiguity with languages, let's look at some of the basic definition which will set the tone for today's section and subsequent ones in building your career in natural language processing. The first one is phonology. So the term phonology, right, is generally used to describe the study of speech. Of course, in elementary English, we learn how to pronounce some words, phonology, some words in phonetics. And the rules also, there are some rules that controls such in pronouncing such words. So you see that there are some certain languages that the first letter, or there are some certain words that the first letter is kind of silent. For example, the word psychology. You can see that the P is silent. And if you are to pronounce it based on the way you hear the word, you may likely start with X, means for Sierra, or C, psychology. So that could be the thing. I mean, assuming you don't know that the P there is silent. Now, I was having a chat with someone and the person was like, this English stuff, I don't understand. If that P is silent, why is that P there? You see, so that is the peculiarity of language. And in different languages, there are peculiarities in it. And that's the beauty of natural language processing, to make computers to understand it. The next one is the morphology. In linguistics, right, morphology is just the study of words and how they are formed and the relationships to other words in the same language. So what this does is trying to help. I mean, in NLP, what morphology tries to do is to see how words can be built out of morphemes. I mean, I've mentioned the next definition, which is morpheme, but what morpheme means there is the smallest unit of meaning in a grammatic function. So let's look at this English word, the word read, R-E-A-D, and let's add X to it. Some people will say read, reads. So you see that word contains a vowel sound, that is EA, that is in the middle of that word. Now it contains a consonant D, and you see that, and the initial sound of the word sounds with R, read. So in that context, right? Can you still hear me? If you can hear me, just type in the chat, yes, 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 yes. Oh, great. Thank you. Because I think I had a sound from my headphones. I was thinking I'm disconnected. Thank you so much. Thank you so much. It's good to know that you are still tuned in. Okay, so I'm talking about morphology, and I'm trying to use the word read or read with the word X. You see that when you want to pronounce it, it starts with a sound R, and which have a different meaning in English. So as a result, they are just sounds rather than the morpheme its words that makes up that word read. So, but that word read is more than just a collection of the letters or the sounds that I need. It's also, there's a purpose for it, right? It may not be simple, right, to explain its meaning of read, but you see that the next letter or the sound X in it adds an entire meaning to it. So when you have the word read and you have X in it, it adds a different meaning to it. And it in this case, by adding that present tense, it creates it as a present tense, and adding that present tense makes it as a single person, and therefore regard it as a morpheme. Now, having explained morpheme, let's look at the word syntax. Let's look at the word syntax. Syntax is the arrangement of words in a sentence, clause, or phrases. And the study of this formation of these sentences, right, and the relationships of their component parts, it's very, very important because it helps us to create how words are designed, or the patterns of words. For example, Sebastian understands NLP. You see that syntax itself, the most basic syntax follows one, a subject plus a verb, now plus a direct object formula. So with that example, Sebastian understands NLP. The role of syntax in that is to make us understand that it is not one, it won't give meaning if we should translate it the other way around, saying understand Sebastian NLP. So the role of syntax in NLP is to help to arrange, to understand the arrangement of words in sentences, either in clause or in phrases, and the way these sentences are being formed, showing their relationships and the component parts. Let's look at the word semantics. Semantic. I mean, you would have been hearing the word semantic, but what does it mean to NLP? So semantic is a concept used to describe how people distinguish between word meaning itself in everyday speech. We could also define it, or we could say it could be the study of how meaning is created out from words and expressed in a spoken or in a written language. And the focus of this semantic is strictly in linguistic. Now, let's look at this example there. We have these two words, cruise and charming. Let's start with cruise. Let's consider the word cruise. It can have different meaning in context. Let's say boats can cruise, car can cruise, people can cruise in their career and the likes of them. You can use it and it makes different meanings. It creates different meanings. But now let's look at another example, the word charming. Now, when you use the word charming, and it depends on the person's actions and temperament. Let's say, for example, someone is charming. Oh, this dude is charming or something. You see that it depends on the temperament of that person you are saying that to, because the person can see it as a mockery or the person can see it as a sincere compliment. So that is what semantic tries to do, tries to distinguish or concern with the meaning of words and how to combine these words either in phrases or in a sentence. The next one is pragmatic. But before I conclude on this semantic, you see that when circumstances are sufficiently semantic ambiguous, right? It can be difficult somehow to simply interpret to interpret the meaning. And in fact, when you look at some of these comedies, mysteries, and other films or movie industries, they rely precisely on this kind of ambiguity in order to generate most of their turmoil or most of their sense of humor. So it is very key for you to understand the role this plays in NLP when you are trying to build an NLP system, when you are trying to either build a sentiment analysis within these words, because these are, we have all these packages that try to help us to understand it, but behind the scene, these are some of the things that were put into consideration before building the packages and making computers to understand language in its reality. Now, let's look at the pragmatic aspect of it. How can we determine a sentence? How can we determine how can we determine a sentence intended meaning? Because we've looked at semantic and we said it depends on temperament or depends on looking at the word charming. Now, the question is, how do we make computers to understand the sentence intended meaning? This is purely what pragmatic is all about. So the solutions might be simply to understand that the meaning of each word is either in a phrase, and which can help to define, and let's say it can also be used in each sentences to make a combination of words. Now, the meaning of sentences can depend on so many factors, because beside the words itself. So that is what that's what pragmatic is trying to do, to complement the semantic aspect of it. Now, the next word we need to look at is discourse. This deals with how immediately preceding sentences can affect the interpretation of the next sentence. We are going to look at these examples in this slide, in a few slides to come. Then the word knowledge, it includes the general knowledge about the word. So you may want to have a glance of all this because we are going to be using using it and see how it plays out in NLP, in understanding NLP, or in this section, which is the introductory part or introductory section of understanding NLP. Now, the next one we are going to look at right now is types of NLP. Amazing insights, what have been created in the field of NLP from systems, from systems, AI systems, doing amazing things, recommended systems and the likes of them. But how did all of these things start into existence? Now you see that the first one there is the keyword extraction, right? And let me say this, one of the key advantages of having computer to understand human language is that in contrast to human, right, they are extraordinarily fast and reliable. So you could see that when you ask someone, oh, 245,000 times 560, it may take a little. You see human trying to pause to make that findings, but with computer or with calculator, once you type it, the result comes into play. So that is one of the key advantages. So if we can make computers to understand human language, it's going to be to an advantage, which was one of the problem statements of NLP, and that created the state of art that we are into. And you see that in many enterprise cases, the content with the most important information in it is written down in natural language. So how does all of these things comes into existence? The first one is the keyword extraction. You could have a system, for example, you could build a system, or let's say you are retracting tweets, or you are looking through emails or something and you want to classify it. So with the first NLP system type of NLP, the first one is all about keyword extraction. You just tell you, okay, so if you see this kind of words in this statement or in this tweet or in this text, then you classify it as this particular word. For example, what we have there is the word delay. So let's say you have a tweet in example 1 or a text or in any format, and it says, and in that line of sentence, when you see the word delay, it means you classify it as delay. You now see that we regret the inconveniences. That is caused due to delay. Automatically, this will be picked up as a delay. Now let's look at the example 2. I made an application and I'm still waiting. Looking at this second example, obviously the keyword extraction delay is not there, but the system will not classify it as a delay, probably classify it as something else. But because the instruction you've given is to classify it as delay, then it's being classified, it won't be classified as delay. But that particular sentence is talking about delay. Now, the first question is, how accurate can this be when you are walking through a large volume of data sets if you are using keyword extraction? So because of the inaccuracy of this, the next stage of it is what is called the rule-based. Now in rule-based, it simply follows this rule to categorize the languages that it's trying to analyze. So the context of this is, if the rule does not exist, the system will be unable to understand. For example, if you have created rules on your Outlook, you created a folder for those I'm just trying to use this as an example. So if you create a folder in your mailbox, in your Gmail or in your mail account, and you said, oh, I want this particular mail from this social person to move into that mail. So what if a mail comes in that is not from this person, but is talking about the same thing? Or let's say in a company, the mail from, let's say from Teju, because that's the face that I'm seeing on my screen. The mail from Teju, I set a room, said any mail from Teju goes to this folder. And let it be that Benga was the one that sent the email, and both of them are from DSN platform. You'll see that I'll definitely miss it. And that's the challenge with NLP as regards to rule based. So this means that the accuracy is dependent on the rules that it's being provided. And as you can see from keyword extraction and rule based, it's very simple to create, but it creates inaccuracy, or it can make your task not to be accurate. And just imagine when you have over a large corpus, or you have a large piece of text that you are applying this kind of either rule-based or keyword extraction, you see that it's going to mess up the analysis or the insight that you are trying to generate. Now, the one that actually created the breakthrough that we have in NLP is the machine learning, which is also called statistical inference. Now, this doesn't blindly tag keywords or rules together. What this tries to do is to try to infer meaning based on the patterns between words and the wider context of the sentence and the paragraph or sentence which it sits within. Let's take, for example, consider this task. Let's say you have a task to identify all the charts and all the tweets, or you have a piece of text that you want to identify charts of, you have users, or okay, let's say, for example, you have a piece of text where you have users who are making their inquiries, and you have a product that you want to sell, and you want to identify, or you are given a task to identify which of these users that are asking for their refund. They bought a product and the product is fit for purpose and they're asking for refund. What do you do in that context? So if you use a rule-based or NLP, it's going to mess up the tasks that you are doing. But with rule-based, with machine learning or statistical inference, let's say someone tweets or sends a chat, or you see a chat that said, I don't want a refund. Automatically, the machine learning system will classify that this person doesn't want a refund, or this person is not talking about refund, and picks up other ones that talks about refund. That is the beauty of machine learning type of NLP or statistical inference in NLP. Let's quickly look at the components of NLP. One, we have the natural language understanding and we have the natural language generation. Now, these are the two components that makes up natural language processing. You have to understand the language and you have to think about how to generate this language. And in this context, there are different ambiguities that embed in all of this. So we have the lexical ambiguity. You see that humans seems to use languages so naturally, yes, but this is not the case, because when we are able to express our views in language accurately, right, in addition to being able to comprehend what others are trying to say, now our capacity will tend to extend not just by interpreting the language, but also includes in the creation of that language itself. So in natural language understanding that there are ambiguities is the biggest thing that's in the field of NLP that have been overcome in trying to make computers to understand. Now, if you remember the basic definitions that we've laid already, if we look at the basic definitions that we've made already, you see that the lexical ambiguity is when you have in a sentence, you have in a sentence two or more possible meanings to a single word. For example, on the screen, I saw a bat. The first question would be, what type of bat? Do you mean the ones that are classified under mammals or bird categories, or are you talking about bats being used by sports for hockey, athletics, and the likes of them? That is part of lexical ambiguity that has been overcome. The next one is the syntactic ambiguity. Let's look at the example there. So it means in the presence of two or more possible meanings within a single sentence or in a sequence of words. The first example there is the professor said on Monday he'll give an exam. Now, what does that really mean? If I open this now, we'll see a lot of comments that will be coming up. So are you saying that the professor said that the examination will be given on Monday, or are you saying that on Monday, the professor said that the exam will be given on Monday? Different meanings to it and different ambiguity, and computer is meant to understand this. Can you still hear me? Please, if you can hear me, just type yes, 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 yes on the chat, so I know that you are still on the call. All right. Thank you. So I must say that the state of art that have been reached in NLP is commendable. So for computers to differentiate and understand the lexical ambiguity in a language, right? So what does this mean? We can have two different meanings from that sentence. And I've already said that it could mean that it was on Monday that the professor told the class that the exam will be administered, or that the exam will be given on Monday. So these things can come in different meanings, and we need to make computers to understand it. So this sentence, the next sentence there means the burglar threatened the student with a knife. This could also mean, right? This sentence could also mean that It's either that, the sentence also could mean that a knife-wielding burglar threatened the student, or that the student was threatened with the student was holding a knife and was threatened with a burglar. So you can see that it comes with its own ambiguity. Then the next one is the referential ambiguity. You see that in referential ambiguity, there are certain entity or entities that this particular sentence is pointing to, and which can result because there may be presence of pronouns in that statement. Let's look at this example one. The boy told his father the theft. He was very upset. The boy told his father theft. He was very upset. This is referential ambiguous because it can refer to both the boy and the father. Example two is Jones went to work. He said, I'm fatigued. Jones went to work. So the next question you ask is, who exactly is tired or fatigued in this statement? Now, the next part we need to look at is natural language generation. This knowledge is derived from NLU, that's natural language understanding. The knowledge is derived from NLU, and it comprises text planning, sentence planning, text realization. But you need to know that in natural language understanding, we have speech recognition, name entity. In natural language generation, that's where we have question and answer, semantic, text generations, the poems, and the likes of them. Let's quickly look at the basic background theory in NLP. Language is symbol, and symbols are not just an invention of logic or classical AI. But when human kind of communicates, right, it involves this symbol, but its communication uses more like a continuous substrate. So, and commonly we have the gestures, which would be sign language, hand gestures, and the likes of them. We have sound as well. Then we have images or writing. Then let's look at the four stages of language representation. You see, naturally, language can be in form of speech, OCR technicization, can be in form of speech or OCR technicization, which you are seeing on the left-hand side of the screen. Now, for speech itself, that's where we've talked about the phonetic and the phonology of it. And we've mentioned that the phonetic is the study of language at different level of sound, while phonology is the study of the combination of sound into organized speech. The optical character recognition, which is the second part, is the electronic or mechanical conversions of images or text. So you see that no matter how this text, in natural language processing, in any form that this text comes into, the language will pass through four processes or four phases, which is the morphologically analysis, syntactic analysis, semantic interpretation, and discourse processing. We've actually defined it in the basic definition, but let me just speak a little before we look at the benefits of NLP. So for morphologically, in a bid for computers to be genius through NLP, three tags that brings to mind is the thought process, the presentation itself, and the representation. Thought process, presentation, and the presentation of language inputs itself. So these bring morphological analysis, such as part of speech, the meaning, the transfer to sentence level, to ascertain the word order or the grammatic structure or the grammar of a sentence with the help of the morphemes, which is the smallest meaning within a linguistic. So in summary, you see that morphology analysis is the structure of the word itself, the relationship to the other words associated with it, which include the stems, the root words, the prefix, the suffix that are in the word. So words can have internal structure, but only applicable to complex words. For example, simple words can be split into smaller parts. That's when we talk about morphemes. Let's look at this word, player. We have play, we have addition of EI, which is the affix, means player. That is morphological analysis. Now the syntactic analysis, which we've talked about already, this tries to make an attempt to analyze the sentence words itself in order to determine the grammatic structure. This American scientist is one of the great contributors in NLP, Naomi Chomsky. And in this, he created two concepts, which is the context-free grammar and the top-down parser. In context-free grammar, what it tries to do is create a phrase structure rule. It's trying to create a phrase structure rule. And in that phrase structure rule, what it tries to look at is, for a sentence, we have the noun phrase, we have the verbal phrase, So, but let me just say this, that this rules tries to ascertain a symbol that may be expanded in a tree format or in a sequence. Now, the new logic here is that if there are two strings, that's the noun phrase, verb phrase, then the strings combine together by a noun phrase followed by a verb phrase to form a sentence. And that is the structure that we have there. So for a sentence, we have the noun phrase, the verb phrase. For the noun phrase, we have the determinants of the adjectives. And when we dive deep in another section of part of speech tagging, this will actually make sense. But just bear at the back of your mind that these are the structures informing a sentence. These are part of the things that was actually built in order for computers to understand how sentences are formed and in order to solve the ambiguities that are embedded in it. So the prepositions, where we have the preposition, where we have the noun phrase, and the verb phrase, where we have a function of the verb, the noun phrase, and the adjective. So all of these things are what tries to create a contents-free grammar. Now, when we take it down to the determinants, where we have the tree paths by the right-hand side, you see that we have, for example, there we have the bird pecks the grain. The bird pecks the grain, where the tree flow forms there, the noun phrase. We have the noun phrase, we have the determinant, we have the noun that makes up the bird. Then we have the verb phrase, the pecks, the verb, the determinant, the noun phrase, which comprises of the determinant and the noun, which is pecks and the grain. So now, considering it, what are the metrics? Now, the metric is that this simplest type of grammar is what is widely used. And the demerits about it is that they are highly precise. For example, the grain pegs the bird is just syntactically correct according to Parser, but even if it makes no sense, Parser takes it as a correct sentence. Now, to bring out a high precision, multiple sets of grammars need to be prepared. Now, let's look at the top-down parser. Now, here, the parser starts with the symbol X and attempts to write it in a sequence. But the demerit here is that it is simple to implement. That's the truth. And for the demerit, it's inefficient, as the search process has to be repeated in an error. It has to be repeated even though an error occurs. That's the two sides of it. Then we look at the third steps that language pass through, which is the semantic. We've talked about it already, the study of meaning and how it concerns the principles of human language. So often human communicates that this fixation is not how they communicate, and this leads to the loss of communication issues. We've seen it severally. This person saying, oh, you mean this? No, this person means this. And even with a smart device, there are some commands you give to Siri, and Siri said, I'm not sure I have a clear understanding of this, because the semantic tries to play a vital role in a language, because native speakers tend to assign interpretations to a sentence. And this also boils down to our intonations, because it differs from people. So someone from the European side of the country, you see that the intonation is kind of different from someone from Africa. Now, the next one is the discourse. Is a compulsory part of NLP, but this sits within the language structure. Now, all of these things are the basic theories in NLP. The beauty of it is that we've already seen how it's been applicated, and I'm going to hand over to my colleague who will lead us on the benefits of NLP for businesses.
Sorry, hello, can you hear me?
I can hear you.
Okay. All right. I'll be fast. Sorry, yeah, I guess based on all he has said, I believe everyone has been exposed to using NLP either directly or indirectly. So I'll just talking about the benefits of NLP to business. So the first benefit to business is large-scale analysis. With the understanding that businesses on a normal day generate lots of data, and this data could come in form of contract, the documents, and the data could come from internet systems, emails, social media, online reviews, and analyzing this data manually could be strenuous. So with the use of NLP technologies, this data could be analyzed with ease, and the insights in the data could easily be gotten from NLP analysis. Now, in summary, NLP is scalable. you can immediately meet any analytical needs and see results using NLP technologies. Then you can analyze and evaluate your competitors' product offerings. Now, this is based on what the market is saying about your products and what the market is saying about your competitors' products. You'll be able to spot identify the problems, identify your shortcomings, or probably identify what you are doing better and they are not doing. So with that, you get like a full insight into, that is like a sentiment analysis, like you mentioned earlier. You get insight into what the market is saying about your product. Then understanding several languages, dialects, slangs, and jargons. Now about the several languages, I know there's some business websites that have options where you could either translate the page from English to other languages. So, and that is like an NLP and an application businesses are currently using. So with that, you're able to serve your customers better. You know that you're also accounting for not just your English-speaking customers, you're also accounting for customers that understand other languages. Then immediate customer services. Now with the use of chatbots, I don't know, I think every business right now, if you access their website, you definitely see option for a chatbot. Or with just chatbot, sometimes they kind of say, hi, hello, I'm you, or something. They come to you to ask if you need any help or anything. Now with these chatbots engage large audience with limited resources. And through the use of chatbots, it reduces the wait time customers have to wait to speak with a human agent to get their problem resolved or something. And then the chatbots are actually trained using mostly repetitive complaints or repetitive questions that customers are always asking. So with that in place, it will actually reduce the wait time customers have to wait to speak with a human agent, and also lead to quick resolution, which on the long run leads to customer satisfaction and improve customer retention and acquisition. And then the next option is identifying patterns in customer communication. Now, from what the customers are saying, you can actually get insight into what customers are saying. If they are doing a sentiment analysis into your customers' reviews online, you can actually know if the feedback you're getting from your customers are either good or bad. And from there, you know how to actually serve these customers better in the long run. And streamline processes and reduce costs. Like I earlier mentioned, businesses generate lots of data on a daily basis. And if this data are actually analyzed manually, it could be very strenuous. And in fact, it's a lot of work for humans to actually analyze this data manually. Now, with the use of NLP, this data could be analyzed at real time, and then businesses are actually getting insight into what the data is saying. And then automated repetitive tasks, that's when humans actually have to go through this thing on a regular basis to actually get this insight manually. It could be very, very strenuous, and it's not even that effective. However, with the use of NLP technology, these insights could be gotten real time, and then yeah, if you can get in real time, and then a quick resolution could be done based on that. Then improve market insights. Now, which is like what I've mentioned earlier, you could actually know how your product or service is doing based on what people are saying about what they're currently saying about it on social media, or based on, let's use e-commerce for example. If you buy a product that you are not comfortable with or you don't like it, most customers just drop their review there. And with that review and that rating, actually the next person that wants to buy would not want to buy the product or even go for the service because of the bad review that product has actually gotten. So that is actually a way businesses actually know how their products or their service is doing, basically. And then from sentiment analysis, you can actually know if the reviews you're getting online, if they are positive or if they are negative or if they are neutral. So with that, you'll be able to resolve your business problem in the long run. Now, statistics by chatbot magazine shows how you can reduce your customer service cost up to 30% just by implementing automotive predefined tasks using NLP. So like I mentioned, with the chatbots, the wait time that customers have to wait before they speak to the customer agent, or maybe a task that could easily be resolved using the chatbot would actually reduce and also lead to a quick resolution for customers' complaints, basically. So the benefit of NLP to businesses could not, the benefit of NLP to businesses could just help improve business process in the long run, and just help reduce repetitive tasks and then lead to better customer service, basically. Thank you.
All right, so I think we've come to the end of today's section on the introductory concept of NLP. So I will hand over for questions or comments as regards to this. Thank you.
Thank you very much. Thank you, Sebastian. Thank you, Oluchi. This was an interesting and an impacting section. Thank you very, very much. I'm very glad to have this session. Kindly, please, everyone, drop an emoji to appreciate our facilitator for today's section. A fire emoji, or those awesome emojis that we can just use to celebrate Sebastian and Oluchi. These are mind-blowing and an eye-opening section. Okay, so before we move on, kindly drop your questions in the chat box, so that we can actually pick it from there. Okay, so that they can attend to the questions. So thank you very much. Wow, thank you very much for this. Okay, so I'm expecting your question. Okay, so we have a question here. Okay, so supposing I'm inviting to come class, but you replied, I don't think I can make it, and then also respond to you as, please don't come. My response to you is not really saying you should not come, but more likely an irony. How do we go about it? Okay, so the question here is just, Sebastian is just referring to irony, how we make our brute natural language, how we handle irony in NLP. I don't know if you can just kindly attend to that.
So what it tries to do is to look at the discourse processing first, then tries to look at the discourse processing takes the last sentence that comes into view in that statement. So if I should look at what you've said, suppose I'm inviting to come class, but you replied as, I don't think I can make it, and then also respond to you as, please don't come. My response to you is not really saying you should not come, but like an irony. How do we go about it? So it looks at this, it will go through the 4 processes which I've talked about. And the first process is, which is the semantic, the pragmatic, and the discourse, in order to identify. So in between all of these things, that we still have what we call part of speech tagging that looks at the inference between the statistical means from one of the scores of each of these words in order to derive the meaning of what is being generated. I can send you a workbook on how those treating ironies in a statement can be, but this example you've given is not a typical example of an irony. But if you are dealing with irony, it goes through that thought process and gives that inference.
Okay, thank you very much, Sebastian. Okay, so we have another question here. Kindly confirm, Gaba, kindly confirm if Sebastian has answered your question. Okay, so we have another question here from Chinazoa. Okay, Chinaza, yeah. So how is data analysis related to NLP? Can we use Python in NLP? I think a colleague of mine have answered that. Okay, that yes, we can use Python for NLP. Okay, and we also carry out analysis, especially sentiment analysis, also an analysis. Is analysis we carry out on language, was on text. Okay, so we have another one here. It said, with what was explained, does it mean I need to consider these basics when building or deploying a chatbot? Okay, so Sebastian, can you please help with that? Okay, so I said, based on these basis, does it mean that it needs to consider the basic we just introduced to in deploying a chatbot, in building and deploying a chatbot?
Yes, you need to consider all of these things. You know, the challenge is in chatbot, we have already imported package where people try to build an already made framework. But if you want to design your own chatbot from the scratch, and you have to design all of these things, you need the idea and concept of this. Let's take, for example, I've seen a chatbot that you type an iron, it returns back something to you. Just be like, how well trained is this chatbot? And looking at the next concept of federated analytics, where we take analytics to data rather than bringing data to analytics, you need to also understand how all these things comes out. Because when you are importing package in Python or in any plumber to build what you want to build, and you get an output, there is a big challenge there. If you don't understand these theoretical concepts, then you are set off to be messed up with your algorithm, or when you deploy it to a larger inference. But when you have an understanding of this, you can easily do a spot check to tell you that, okay, I think something is wrong in between when you're trying to build this system.
Thank you very much for answering this question. So we also have another one here. It said, could you briefly explain how named entity recognition works? For example, how to identify which Trump is being referred to in a text.
Okay, so name entity, what name entity does? Yes, I can, but I need to demonstrate it. And maybe you can contact DSN. Let's take it further than that and show you how it works in a live environment. So, but name entity, what it entails is trying to locate the key information in a text. So if you want to identify the word Trump that you are referring to in a text, and that is the keyword that you want to identify, then name entity can create that system for you. But the most important details is what it focuses on. And when it does that, it tries to classify them into a number of predetermined categories which you've created. That is where you can have concepts like tests, topic modeling, and the likes of them come into existence. So, and it does this in two ways. One, to identify the entity. So if the entity is Trump in that text, it will identify the entity from the text, pass through the 4 stages of language understanding that we've talked about, and then classify it. So that's how name entity recognition works. But I think if you see how, I have a notebook that explains that, so that when you pass a piece of text, you see how it comes out in reality.
Okay, thank you very much. We have another question here. Okay, so the question is, the person asks for material and resources that you would like to recommend for a beginner in NLP, to advance in NLP. Okay, and then yes, we are going to have sections. We are going to have more of these sections, so you can just follow with us. But Sebastian, can you please answer the? Okay, the resources will be shared. So then let us just waste much time on that.
The resources will be shared, and unfortunately, if you don't if you did not register for this section, you may not get the resources. And in that resources, I'm going to include a roadmap that you need to follow, or a roadmap map in getting into NLP.
Okay, thank you very much. Okay, so we have the last question that I will be asking from this end. Okay. Can machine communicate with humans with natural language, like a car tells their thoughts in a natural language? Please first respond to that.
Yes, that is the work that is being, that's the work that is currently being done, even as of now. Yes. So if a car dictates and thought, it can tell you. There are devices like that. The one there is one that I know someone uses in order to tell to give the person the information in its own dialect in Chinese about it. So there are devices already working in that line. Now, what we need to do is to plug in transformers alongside with machine learning translation concept in order to translate it to 7,151 languages that we have in the world.
So thank you very much. Okay, so we have another question here. Okay, so is NLP embedded into another system? And this third question is the relationship between NLP and ontology. And then the fourth one, which is the last one, is areas of dissertation in NLP. That's area of research. Okay, so Sebastian.
Okay, this is going to take a whole lot of time to answer. So yes, NLP is embedded in another system. Let's talk, for example, when you're talking about computer vision, right? Some people will argue that it's not part of NLP. Some people argue that it's part of NLP. That's the system, but when you look at it, NLP is embedded in it. So NLP, yes, can be embedded in another system. NLP is all about trying to make computers understand human language or try to understand text. Maybe it's the language that I'm using there that is confusing, trying to understand text. And text are what humans use in communicating. So NLP can be embedded in another system. Then the relationship between NLP, I'm not sure what you mean by ontology, but I think ontology is all about metaphysics, dealing with the nature of being. The relationships between there is there a text involved in it? If there is a text involved in it, then NLP can be used for it. NLP concept, techniques, and NLP concept and techniques can be used in it. So we can have this conversation further for me to understand the area of ontology. But answer me, if the answer is yes, text is embedded in NLP in ontology, then NLP is a very good thing to use. Then areas of dissertation in NLP, well, there are so much. All you just need to do is to look around you and to find out what are some of the challenges and if those challenges involve text and what can be done. Now, I don't know if you've heard about this software used in some parts, Turnitin. I have a very big sentiment about Turnitin, and that's a very good area where where you can also research, because you can see that when you use Turnitin as a software, there are some words that it will flag up for you, and that word cannot be changed. Let's say, for example, artificial intelligence. If you include artificial intelligence in any of your materials and you pass it through Turnitin, it's going to flag it for you. But the fact still remains that you can't change that. You can't change the word artificial intelligence. Now, the question is, how do we build a system or modify Turnitin in order to pick artificial intelligence, pass the sentence through the 4 stages that we've talked about, and at the same time, make sure that this is not actually supposed to be a similarity or a plagiarism situation. So that is a very big area that I'm passionate about. Then we can extend it to the areas of health. Now, that's why I said this is big. Topic modeling is there. The vaccine that was created for COVID within a year plus, of course, producing a vaccine takes 10 years to be done, but it was produced within a year. How did they achieve that? Through natural language processing, in building topic modelings that identify the strengths and the genetic makeups of the virus in order to build that. So there are several project topics that are embedded in it. Maybe we can take this offline and I'll give you more ideas on some of the open solutions in NLP that can be solved.
Okay, thank you very, very much. I'm sure we have responded to you have responded to those questions. So thank you very much for taking time to respond to this question. So conversation is going to continue on our platform. So kindly make sure you join our platform. Okay, so let's just move straight to the few updates I would like to give our community members. Yes, wow, I'm sure you're excited already seeing these flyers. Yes, we are having AI Health Day continues this week, and then we're having the business analytic track and hard track. Okay, so we'll be having the business analytic track on Monday, and then the hard track on Tuesday. I'm sure you won't want to miss these sections. Also, our French class on introduction to Python programming language also continues next week, Thursday. So make it a date. Just schedule yourself and tick this date in your calendar. Okay, so. And thank you very much, everyone, for joining this. If you are not yet a member of our community, my colleagues should be dropping some links in the chat box where you can use to join the community. So here are our our social media handles that you can actually follow us and get updates and opportunity from us, real life updates and opportunity from us. So I want to say thank you to our facilitator. Thank you, Oluchi. Thank you, Sebastian, for making this section an awesome one. Hope to see you facilitate more section for the DSN community. So thank you, participants. Thank you, everyone. So please, an emoji to celebrate yourself for joining this section, this awesome session. I'm sure you've learned a lot. So I just drop an emoji to celebrate yourself. Let's just do that as we end this section for today. So thank you very much, and do have a lovely weekend. Okay, bye.